I'm just taking the 24 over to the other side. I then took half of this. You don't know why yet. I'm going to teach you why in a minute. Okay? You're just hanging with me here. I took half of it and squared it. This is what we call completing the square. Okay? And I added that value to both sides of the equation. Have I really changed the equation adding the same thing to both sides? No. Can I add the same thing to both sides all day long if I want? Think about this equation. I have kids in Algebra 1, they do this all the time. Equals 5. Okay, and they'll say, oh, you should subtract 5 from both. Oh, Sam did this just 2 seconds ago, right? And she said, just subtract 5 from both sides. I'm like, okay, let's do that. And we end up with, and you're like, well, that didn't get me anywhere. But could I do that all day long? Yeah, all right, let's subtract 8 more. Okay, we'll subtract 8 more.
My bad.
Could I just keep random? Oh, let's just add 10. Sure, add 10. Where did that come from? Nobody knows. Just do it. All right, fine. Eventually, what are you going to do? Now I'm going to what? Now that I'm at this point, what am I going to do?
Add 6.
I'm now going to add 6 because I'm like, wait, I want to get that by itself. Okay, but could I sit there and all day long add those over and over and over again as much as I want on any side? Yeah, as long as you're adding the same value to both sides, have you really created an inequality? No, if you have the same value to both sides, it's still what? Equal, right? If you have the same amount on one side as you have on the other added to it, it's still equal. It's like a scale that balances out, right? All right, so by adding 25/4 to both sides, I haven't really changed the problem. I've changed the nature of the problem, but I haven't changed the equality. It's still equal, right? It's the same thing when I added 24 to both sides. 24, I added it to both sides. All right, so now, what's this side going to be? I need a common what? This is where Aspen just talked about it. What do I need a common what? Denominator. So I need this to be a what? A 4. So I need to take 24 times what? 4. What's 24 times 4? 96 plus 25 is 121?
Yeah.
Over what? 4. Okay. Okay, that's all nice and good. Now the whole reason I completed the square on the left side is because now I have a perfect square triangle. Believe it or not. What's the square root of 25/4? 5/4. What is, or 5 halves, right? 5 halves. What's half of the middle term? 5 halves, right? So I've actually created a perfect square trinomial. This is one set of parentheses squared. Okay, because it's a perfect square trinomial. Square root x, square root 5 halves. Notice that that's half of that middle term. Okay, and what goes right here? Negative. Okay, equals what? 121 over what? 4. Okay, that's nice. Can you solve that the way we've just solved from 4.3? You can take the square root of both sides. Well, can I take the square root of both sides, right? Can I?
Yeah.
Sure. What's the square root of this left side? X minus 5 halves. What's the square root of this side? Plus or minus what? 11 over what? 2. What should I do to both sides? Add 5 halves. X equals 5 halves plus or minus 11 halves. 5 plus 11 is? What's 5 plus 11? 16 halves. What does 16 halves equal?
8.
Five minus 11 is? Negative 6 halves is? Did I get the exact same answer? How come I got the same answer? I'm a super freaking genius. Yes?
Why would you ever do that?
Why would you ever do that? That is the most excellent question. And here's the answer. Because it always isn't factorable.
No.
Yes. So, Obviously, if this is factorable, would I ever do that?
No.
No! What if it's not? What if it's not factorable and you want to find the zeros? Well, we've learned one way to find the zeros if it's not factorable, but it only gives us a decimal. It doesn't tell us the whole entire answer because it doesn't tell us the exact root, okay? It doesn't give us an exact answer. How can we approximate the answer if it doesn't factor? We could graph it on our graphing calculator and find it, right? That's still easier than that. But will it give us an exact answer? No. Will this give us an exact answer? Yes. Now let me show you how they came up with this. You're like, what the heck? How did he even know to do that? How did he know to do that? I'll show you how I know. Watch. What's this? Standard form of any what? Any quadratic equation. Oh wait, I don't want to show you this yet. Sorry, we'll do this next time. Sorry, I'm getting ahead of myself. Sometimes I do that, I get too excited. We'll get there, but we want to work on just completing the square. Now what else might completing the square come in handy? Why else might you want to do it? Okay, watch here. What's the vertex? You would first start out by doing opposite of b over 2a, and he's saying it's going to be a negative 1 x coordinate. You plug that in and find it, right? Watch. There's another way. There's always another way. If anything math should teach you is there's always another way. Don't get stuck in one way. Okay, watch this way. I'm going to group this together. I'm going to complete the square and make a perfect square trinomial. Okay, and then it'll be in vertex form. What's vertex form? This is standard form, right? What's vertex form? Ax minus what? H squared plus what? K. That's what we call what form? Vertex form. Okay, and then I would know the vertex, right? I'm going to change this to vertex form by completing the square. That's what this is called that I'm doing. Now, how did I complete the square? Think about what I did right here. I took half of the linear coefficient. This is what you want to write in your notes. These are the steps to completing the square. Okay? Steps to completing the square. Okay? Always take half of the linear coefficient. Half of 2 is what? 1. Where did this 2 come from? Where did that 2 come from? It's the number in front of the x. So half of the linear coefficient, I'm taking half of the linear coefficient, okay? Then I square this value, this is called completing the square. Half of the linear coefficient, square it, and that has completed the square. So my completed square is what? 1. The reason you complete the square is to create one set of parentheses squared. Okay, now watch. X squared plus 2x plus 1. I've added 1 to this equation. I'm not going to work this side. I'm not going to work the right side. Okay, I'm only working the left side. If I add 1 in the parentheses, what do I got to do on the outside of the parentheses to keep it the same? No, if I add 1 on the inside and I add 1 on the outside, what's 1 plus 1? I've added 2 to the equation on this side, left side. I've added nothing on the other. That's a bad thing. If I add 1 on the inside, what should I do on the outside? Subtract 1. Now what have I added? What's 1 minus 1? I haven't added anything. So let's do that. Let's minus 1 on the outside. Everybody agree with that so far? Have I added anything to the equation? Well, yeah, I added 1. But on the outside, what did I do? Minus 1. What's plus 1 minus 1? 0. I zeroed out. Is everybody okay with that? Okay. Now, what's negative 7 minus 1? Negative 8 equals f of x. Okay. What do I have inside of that parenthesis? A perfect square trinomial. The first and last terms are perfect squares. The middle term is double that value, right? The middle term is double that value. 1 times x is x, doubled is 2x. I have a perfect square trinomial. What is this factor to be then? Square root, sign in the middle, squared. Minus what? 8 equals f of x. The vertex is -1, -8. And the a value is 1. And I just turn it into what form? Vertex form. Now, could you have found the vertex and then put it in vertex form? Yeah, you would have taken what? How would have you found it? Negative b over what? 2a. That would have been still -1, right? And then I would have done -1, plugged it in. -1 squared is 1. -1 times 2 is -2. 1 minus 2 is -1. Minus 7 is -8. That's my y coordinate. Then I would have just put it in the vertex form. X plus 1 squared minus 8. Yes?
Where did you get the 1?
Where did I get which one?
The 1.
This one?
Yeah.
Or
No.
this one?
Yeah.
This one?
No.
This one?
Yeah.
This one?
No.
Yes.
Yes.
That's where I got it from.
Oh.
Okay. Because what I did is I took half of the what? Linear coefficient. Half of 2 was what?
Oh, yeah.
1, and 1 squared was? Okay, let's try another one. Let's try another one. Because you guys asked, why would you ever want to do that, right? Okay, watch. Here's another situation. Solve that equation. What could you do? What would you think to do first? I could subtract 11 to the other side, right? But then I'd try and factor it, and what would be the problem? If I subtract 11 to the other side and I set it equal to 0, which is what you should do, I would then say what multiplies to be 11 and subtracts to be 4. And what's your answer? Oh. So what's the solution? Ugh. I don't have a solution, but I do. I can solve this by completing the what? The square. Okay, let's complete the square. So think through the process. Step 1 to completing the square, what did I say it was? Half of the linear coefficient. So memory, what am I going to take half of? 4. The linear term, this is the quadratic term, by the way. I keep saying these words and then you don't know what I'm talking about. This is the quadratic term, the one that's squared. The linear term is the one with the x. The constant term is the one without an x. I should have explained that originally, but. So in ax squared plus bx plus c, right? The ax squared term in the standard form, the ax squared term is referred to as the quadratic term. The bx term is referred to as the what? Linear term. And the c term is referred to as the constant term. You with me? So, first of all, I don't set this equal to 0. I set it equal to the constant if it doesn't factor. Now I complete the square. What's half of 4? Memory said I should take half of 4. That's 2. What should I do with the 2, Sam? Square it. See, this is where this number is coming from, out of nowhere. Okay, 2 squared is what? 4. I'm going to add 4 to this left side. Why in the heck do I even want to add 4 to this side? To create a perfect square trinomial. That's what I'm trying to do. Now that I've created a perfect square trinomial on the left, though, I've added 4 to the left. To keep things equal, I got to add what? 4 to the right. So let's add 4 over here. What's 11 plus 4? 15. Don't forget to add that 4 over there. I have a lot of kids who will put it over here, but they'll forget to put it over here. You got to add it 4 to both sides. Okay? Now it's a perfect square trinomial. What should I put? It factors to be a perfect square, right? So I'm going to put a perfect square there. And what does this become? What's the square root? X. What's the sign of the middle? Plus. What's the square root of 4? 2. If I squared this out, if I took first term squared, first term times second term times 2, last term squared, would you get this? Yes. It's exactly the same, I've just changed the form, how it looks. Okay? All right. Equals what? 15. I haven't changed anything over here, I just changed the form. Okay? Now what should I do? Square root both sides. The left side is what? What's the right side? Plus or minus. Don't forget the minus. Plus or minus square root of what? How many answers am I getting? 2. What should I do next? Minus 2 to both sides, right? So what's x? Negative 2 plus or minus square root of 15. Those are the 2 exact answers. What are the 2 exact answers? Negative 2 plus the square root of 15 is one answer. And negative 2 minus the square root of 15 is the other answer. What's the decimal equivalence? Let's figure this out. So you got it. So by the way, what is the square root of 15? 3.9-ish, right? Is a good guess. Check it and make sure. We're going to go 2 decimal places. Just do square root of 15, but a good guess is seriously about 3.9. What'd you get? 3.87. Okay. You're off by 0.03, right? You're not going to be off by more than 0.05, just guessing. But let's say that was it. So now let's do negative 2 plus 3.87. That's easy. It's what? 1.87. Do you agree with that? And then let's do negative 2 minus 3.87. That's negative what? 5.87. Now, here's what I want you to do. Take out your graphing calculators. Take out your graphing calculators. Is this the same equation as I started with? Is this equation the same equation I started with? Yes or no? Yep. I just what?
Oh, just.
I just brought the 11 over, and that way it was equal to y, or f of x, or whatever you want to call it, right? This created it being a function. This is in standard form. This is able to be graphed. So punch this into your graphing calculator. So I just want you to punch that into your graphing calculator. Go to y equals. Make sure you know how to run it. This is kind of a review, too, for those of you who just got your graphing calculators.
I know that.
Because some of you just got them, and you're still like trying to learn them. So hit y equals, that's the top left key. Use your xt theta key to put in the x value. So hit that xt theta key, it's right next to the right next to the alpha key. Okay, and then hit your x squared key, that's kitty corner to your 7. So you're going to hit x squared, and then you're going to hit what? Plus 4x, you can put that in. Plus 4, hit the xt theta key, it's just quicker. Xt theta. And then you're going to hit minus 11. Make sure you hit minus 11. And then hit enter. Okay, then hit graph. Graph is your top right key. Okay, you're going to graph that. It goes way down, comes back up, right? Okay, now we want to find the zeros. Okay, we want to find the zeros. I'm going to hit second trace, which is second calculate at the top, second key in from the right. Okay, and then you want to hit 0 because you want to find the 0. So go down and hit 2 or hit 2 and hit enter. And now it says I want the left bound. So let's go to the left one first. So I'm going to go clear over on the left using your cursor at the top. Go left with your cursor until you're above the x-axis. So I am at like negative 6 something. Okay? Because I'm left of the 0. Is everybody with me so far? Okay, and then you're going to hit enter, and then you're going to go right of that to get to the next one. You want to go left of that one. Yes, you do. Just go left.
Yeah, but.
It's okay. It'll show. See, there it is. See it cursing? Okay, now it's left. Well, because it says right here what it is. Negative 6.
How do you know where to go up?
Oh, I don't. I don't care. As long as I'm above what? As long as I'm above the 0. Okay? So as long as I'm above, I can hit enter for my left bound. Now it wants the right bound. Now I gotta be below the what? 0. Okay, so the left bound has to be left of it, the 0. And the right bound has to be right of the 0. You with me on that? So it's between there and right. And then it says, do you want me to take a guess? And I'm like, well, duh, I don't know the answer. So I hit enter again for it to make a guess. Make sure you hit enter again for it to make a guess. What was its guess? Negative 5 point what? 2 decimal places.
8-7.
Negative 5.87. What was my exact answer? Hey, can you find your right one? Hit the same thing. Hit calculate. Hit 0. Let's do the one on the right. Left bound, I got to be left of the one on the right. I'm going to wait until I can see my cursor. So I'm at about, I don't know, 1.2 or 1. I'm somewhere around 1 something. I don't care, as long as it's below the one on the right. And then I'm going to go above the one on the right, hit enter again. Now I'm going to say, hey, do you want me to guess? Well, duh, I don't know the answer. Actually, I do, because it's on the board. But it ends up being what? 1 point what? 87. And you're like, holy cow, it matches. Should it match? Well, yeah, it's the zeros. It should match. Okay, and that's because you're going too far to the right. You can't do both at the same time. So I'm going to go over here. You have to do them separately. Now I'm below that 1. I'm focusing in on this point. I've already got my left down. Now I'm doing my right down. Now I'm doing enter. Negative 5.87. So what? I'm going to hit it again. I'm going to do this side this time. I'm going to calculate the 0. See, I can't do both at the same time. I got to do that one or this one. I'm going to do this one over here now. I'm going to do the left down. So I'm going to wait until I'm just below.
That's my bad. That's my bad.
Somewhere. Oh, I can see it now. I'm below it. It doesn't matter. And then you go above it. I've got it surrounded, right? Both left and right. That's what it's saying, left and right.
Jeez.
Now, it wants to guess, which I want it to do. 1.87. You see what I mean? You got to surround the point.
It's scared.
You gotta-
Like, because I my head like dropped, and then all of a sudden this dropped, and I'm like on cold medicine right now. It is not
Do
good.
I see it? And this one I want to go below and then
Then every time I cough, it shakes.
below. Above.
Mm.
Again, I don't